Decide whether the limit exists. If the limit exists, find its value. Limit as x approaches 1 from the positive side of the function f of x, shown here in the graph. As x approaches 1 from the positive side, meaning x is greater than 1. As x approaches 1 from the positive side, the function is approaching a value very close to 3. Therefore, the limit as x approaches 1 from the positive side of the function shown in the graph is approaching a value equals to 3. Limit of product is equal to product of limits. We want to find the limit of the product of two functions f of x and g of x as x approaches negative 6. Rewriting the limit of products as product of limits, we obtain limit as x goes to negative 6 of f of x times limit as x approaches negative 6 of g of x. Substituting the given values, we obtain the limit of the product equals to negative 12. In limit as x approaches a of p of x divided by q of x, if p of a and q of a are both equal to 0, then x minus a is a common factor of p of x and q of x. The limit as x approaches 7 of x squared minus 49 divided by x minus 7 can be written as limit as x approaches 7, rewriting the numerator as a product of x minus 7 and x plus 7, and cancelling out the denominator x minus 7, we obtain limit as x approaches 7 of x plus 7, which is equal to 14. Observe from the graph of the function x squared minus 49 divided by x minus 7. The graph is a linear function with a hole at x equals to 7. Now, as x approaches 7 from both directions, the value of the function is approaching a value equals to 14. Limit of the rational function an x to the n plus so on a naught divided by bm x to the m plus so on b0, where an and bm are not equal to 0, is equal to the limit of the leading terms of the numerator and the denominator. The given function, therefore, is equal to limit as x approaches infinity of the leading term of the numerator, which is negative 6x squared, divided by the leading term of the denominator, which is 3x squared. Cancelling out the common factors x squared, we obtain the limit as x approaches infinity of the given function is equal to negative 2. In this word problem, the employee productivity after S number of on-the-job training is given by this function. We want to determine the productivity of the employee as the employee's training approaches the 5th day. So applying the limit as S approaches 5 to 87 plus 45 times S divided by S plus 7 gives 87 plus 45 times S, which is 5, divided by 5 plus 7. Simplifying, we obtain 87 plus 225 divided by 12, which is equal to 312 divided by 12, which is equal to 26. Find all the points where the function is discontinuous. As we can see from the graph of the function, the graph is approaching a vertical asymptote at x equals to 3. Therefore, the function is discontinuous at x equals to 3. Find all values x equals to a where the function is discontinuous. A rational function given by p of x divided by q of x is discontinuous at points where the denominator q of x is equal to 0. The given function, therefore, is discontinuous when x equals to negative 7. Rewriting the numerator as a product of x minus 7 and x plus 7 and cancelling out the common factor x plus 7 in the numerator and denominator, where x is not equal to negative 7 and f of x is equal to x minus 7, and the function is discontinuous at x equals to negative 7. The common factor x plus 7 here indicates that the graph of the function f of x has a hole at x equals to negative 7. The derivative of a function fails to exist if the graph of a function has corners or cusps, as shown here, and also fails to exist if the graph of a function has a vertical tangent line, and also if a graph has point of discontinuity, such as the one shown here. So the derivative fails at those x values because the given graph has corner points at x equals to negative 2 and at x equals to 2. Find the derivative of the function shown here. Using power rule, we can apply derivative of the sum is equal to sum of the derivatives, and the power rule is the derivative of a function x to the n is n x to the n minus 1 for any real number n. So the derivative f prime of x is 3 times 2x plus 7, which is 6x plus 7. Find the slope of the tangent line of the function at x equals to negative 1. Let f of x equals to x to the 4 plus 3x cubed minus 2x plus 2. The slope of the tangent line is the derivative of the given function, f prime of x. Using power rule, we can write the derivative as f prime of x equals to 4x cubed plus 3 times 3x squared minus 2, which is 4x cubed plus 9x squared minus 2. And the slope of the tangent line at x equals to -1 is obtained by plugging in -1 in the derivative, which gives 4 times -1 cubed plus 9 times -1 squared minus 2, which is equal to -4 plus 9 minus 2 equals 3. In this problem, we use a TI-84 to find the derivative of the given function. First, go to Math, and then scroll down and select N derivative, which is the 8th in the list. And once you see d by dx, you input the independent variable here, which is x, and you input the function here, the given function, and the parentheses, and the value of the derivative at x equals to -2 in this box. And press enter, you'll see the derivative of the function at x equals to -2. The profit in dollars from the sale of x thousand compact disc players is P of x equals to x cubed minus 3x squared plus 7x plus 7. Find the marginal profit when the value of x is at 8. The marginal profit is the derivative of the profit function, which is obtained by using power rule on the given function, which gives P prime of x equals to 3x squared minus 6x plus 7. We want to find the marginal profit at x equals to 8. So plug x equals to 8 in the marginal profit function. We obtain, after simplifying, P prime of 8 is equal to 192 minus 41, which gives $151. Use the product rule to find the derivative. F of x equals to 6x minus 2 times 5x plus 1. If a function f of x is equal to product of u of x times v of x, both are differentiable at x, then the derivative f prime of x is equal to derivative of the first function times the second function plus the first function times the derivative of the second function. So the derivative of the given function f prime of x is derivative of the first function times the second function plus first function times the derivative of the second function, which is equal to 6 times 5x plus 1 plus 6x minus 2 times the derivative of this is 5. Distributing the multiplication, we have 30x plus 6 plus 30x minus 10 equals 60x minus 4. Find the limit of the given piecewise function if the limit exists. Find the limit of the function f of x as x goes to 1. We want to show both the left and right hand limits exist and are equal. Start with finding the limit of the function as x approaches 1 from the negative side, from the left side, meaning x values less than 1. The values of x less than 1 corresponds to the function negative 4x plus 7. So the limit as x goes to 1 from the left side of negative 4x plus 7 is equal to 3. Similarly, limit of the function as x goes to 1 from the positive side of the function f of x, meaning x values greater than 1, and the function that corresponds to x greater than 1 is negative 6x plus 2. So the limit of the function negative 6x plus 2 as x approaches 1 from the positive side is equal to negative 4. Since the left and right hand limits are not equal, the limit does not exist. Find the average rate of change of the function y equals to x squared plus 8x between x equals to 2 and x equals to 4. The average rate of change of the function f of x from x equals to a to x equals to b is given by this formula: f of b minus f of a over b minus a. Here, a is equal to 2, b is equal to 4, and the function f of x is x squared plus 8x. Average rate of change from x equals to 2 to x equals to 4 is equal to f of 4 minus f of 2 over 4 minus 2, which is equal to 4 squared plus 8 times 4 minus of 2 squared plus 8 times 2 divided by 2. This equals 16 plus 32 minus of 4 plus 16 over 2, which simplifies to 48 minus 20 divided by 2, which is equal to 28 over 2 equals to 14. This is the average rate of change.